Yeah. Can anyone please confirm whether my voice is clear, whether the screen is visible or not?
Yes, I can see.
Yes, sir.
Persistence of an RTD, right? What do you mean by persisting in RTD? Means making the RTD available in the RAM, even though the next RTD is ready and computed. Even the next RTD is ready and computed also, the persisted RTD won't be removed from the RAM. Advantage is the other data flows can reuse the executed transformations. Transformations can be reused. Here, mainly the rules you need to follow in persisting in RTD means at least one flow should be executed. At least one flow should be executed. Why that flow should be executed means whenever first flow executed means which RTD you want to persist, that will be persisted in the first flow. From the second flow onwards on, no need to start that flow from the beginning. Already the RTDs which are persisted from there you can, because they will be available to give you the output, right? From there you can execute. A RTD will be persisted when first time they are loaded and computed. Whenever the first time a RTD loaded, at that time only it will be computed and persisted. Wherever you give the persist options, right? But RTD will be persisted when first time they are loaded in. The RTD whose output is commonly used by multiple flows. Persist that RTD. Which RTD will persist? Whose output is commonly used by multiple flows. Persist that RTD. We need to persist the RTD before action is performed. Whenever action is performed, then before that action only we need to persist it. Which RTD to persist means whose output is commonly used by multiple flows, that RTD you persist. For example, sc.text file, spark context.text file, HDFS file path, if you are giving the file path, right? RTD1 R2 equal to R1 dot map. So if you are performing any transformation in RTD, a new RTD got created. On RTD, if you are making any filter transformation, R3 you got. On R3, if you are performing one more R4 you got. On R4, again one more transformation, R5 I got. Now here I am saying R3 dot persist. Will it be persisted? Yes.
Yes, it will.
Yeah. Wherever you give the persist option, the RTD will be persisted, right? The flow execution is as follows. First R1 loads, the partition will be loaded and computed. R2 loads, computed and ready. When R2 is ready, R1 will be removed, I say. R3, whenever the first time RTD is loaded, computed, it will be persisted. Wherever you give the persist option, after R5 or after R50 EQ, whenever first time when the RTD is loaded only, it will be persisted immediately. And now R2 will be removed. But before this is the action, right? Before this action only, you should provide the persist option. Before the action only, we need to give the persist option. R4 loaded and computed, R3 is not removed because R3 is persisted means it won't be removed. R5 loaded, computed and ready, R4 removed. When action is completed, then R5 also removed, right? Now R3 available in the RAM. Whenever I say R5 dot collect, see this data flow. Whenever here I am saying R5 dot collect,
Hello, are you there?
yes. So whenever you say collect, before collect only, the persist option has to be provided. Means once this action is completed, later after this line, if you give the persist option, no RTD remains in the line. So before action only, if you are giving that, before action execution only, the persist. Yes, when R3 is loaded, it will be persisted. Okay. Fine.
Vijay, generally the data flows, right? It's a sequential manner they will be loading, right? One after the other.
Yes.
So when we are giving that R3 dot persist after R5, right?
Mm.
So whether it will be first scanning the code and later it will be executing the steps.
Yes.
Okay, it will look for that persist option wherever it is available, and then immediately it will go for the next step, right?
Yes.
Okay.
Yeah, Vijay, is this the demo or is this the class?
Class, right?
This is class, you meant to say?
Yes.
Okay. But you are not executing anything on, using any editor or something. You're teaching,
Yes, yes.
using the.
Only this, right? From the next session onwards, right? There won't be anything theoretical. Everything will be practical up to the end of the course. Only
Okay.
this. Okay, from the next session onwards, right? There won't be any theoretical up to the end of the course. Everything will be practical only. Okay, but only thing is you need to understand this persistence of an RTD. The important feature of PySpark, right? Persistence. And how
Yeah.
it is loaded and how it is computed, right? Yes. So here, when action execution is completed, then R5 also removed. Okay. Now, R5 dot collect, whenever we say R5 dot collect, right? R5 input is R4. How will you check, right? Whenever you say R5 dot collector, what is R5 input, from where it has to get the input? From R4. For R4, where it has to get the input? From R3. So whenever you are saying any action, right? Whenever you are saying any action, it will check first for R5 from where it has to get the input. For R4, where it has to get R3, R2, R1. Okay, R1 has to get the input from a file. Okay, fine. So from here onwards, the flow executes one by one. R1, R2, R3, R4, R5 gets loaded, and finally R5 output will be collected. During this process, if you have said anything to persist in this flow, if you have said anything to persist, those will be persisted. Now see this multiple flows, right? Yes. So here R1 equal to so how RTD1 R2 equal to R1 dot R3 equal to R2 dot R4 equal to R3 dot. See, R1 equal to R2 equal to R3 equal to R4 equal to R3 dot. Immediately after R3, I will say R3 dot persist. Immediately after R3, I will say R3 dot persist. See this example one. R1, R2, R3, R4, R5. But here I'm saying after R5, R3 dot persist, I'm saying after R5. After R4, I'm giving observe these three flows here. Flow 1, flow 2, and flow 3. Here after R3 I have given, here after R4 I have given, here after R5 I have given. After R1, after R3 I have given persist, here after R4 I have given, after R5 I have given this persist. Which one is valid, which one is invalid in this, which flow? See the three flows.
The last one will be invalid. Are you able to hear me?
Yes.
Yeah, the
We
last
have
one.
not used action yet.
We cannot say directly.
R5 dot collect. Yes. Now try to answer. These three flows.
All are valid. All are valid.
All cases are valid.
So whether you go after R3, whether you go after R4, whether you go after R5. Before action only, right? All these are provided. So all these are valid.
Yeah, now
Wherever you specify the persist option, it will be persisted only when it is first time loaded. When R3 is first time loaded into RAM only, it will be persisted. After R3, if you go, after R4, if you go, after R5, you go, when first time loaded only, it will be persisted. Observe this flow 2. Is this valid if I say in this way? Can we persist two RTDs? Is this valid? R2 dot persist and R3 dot persist, is it valid?
Yes. Yes, we can persist.
Yes.
Yes, you can persist multiple RTDs. Now, is it valid if I say in this way? R2 dot persist, R3 dot persist.
Yes.
No, it is not persist. I think it is not valid.
Valid, right?
It is valid.
It's valid because before action only the persistence is given. Wherever you give persist option, before action only we need to give.
But the same, there is no any modification is going on. So why we need to persist?
R2, R3, I want to persist. They'll be persisted. They'll be in the RAM. They'll be available in the RAM. Only those two. Once the total action executed also, those two remains in the RAM. Now, R3 dot persist. After action I have given. Is it valid?
This is invalid.
Invalid.
Whenever you say R5 dot collector, R1, R2, R3, R4, R5, one by one, they'll be loaded and they'll be removed from the RAM. Once this output is collected, R5 also removed. Now you are saying R3 dot persist. Do you see any RTD in the RAM now? Once your total execution is completed, R5 dot collector, once the R5 output is collected, R5 also removed. No RTD in the RAM. In the next line, you said R3 dot persist. No. R3 is not available. It got removed. You cannot persist it. Invalid. Invalid, right? Okay. Understood, right? If you want to persist RTD, yes. Now persist options. Persistence options of RTD. We got these following options. If you want to memory only, memory underscore SCR, disk only, Memory only, memory underscore SCR only. So these are persistence options of an already 5 options. If we persist R2, is it valid? See, okay, my query was asked. Some query was asked, right? Check it. Now, will the R3 be persistent?
No.
No.
See here, R3 dot collect means your flow executes from R1 to R3. One by one they will be loaded and one by one they will be removed. Only this is the flow that is going to execute. This statement, once action completed, no RTD in the RAM. This statement gives error. This R3 won't be persisted. Now try to say one more example. R3 is not persisted. R3 is not persisted. Now, two actions are there. R3 dot collect and R5 dot collect. Will R3 be persisted?
Yes.
Yes. R3 will be persisted here.
Why, sir?
Hmm?
Why here it will be persisted?
Okay. Whenever I say R5 dot collect, R5 input is what? R4. R4 input is what? R3. R3 input, R2 input, R1, R1 5. So the flow executes from second, for the second action, the flow is going to execute from the starting.
So will it not execute from R3 dot collect? It's not top down.
No, R3 dot collect, for R5 dot collect, the flow executes from the starting. Whenever you said the flow, this is the flow that is executed. Before action, do you see any persist option? For the first action, before the first action, do you see any persist option? No, right?
There is no.
Nothing
So
is,
but
nothing is.
but when the action encounters, then it must start the flow there, or it does not. It starts from the last action.
Yes. Whenever you say, whenever you say the first collector, will start from the last. N6 R3 input is R2, R2 input is R1. None of them are present in the RAM, so it starts from R1. One by one they get loaded. Once this R3 dot collect, no RTD is in the RAM. Whenever you say the second action has no RTD in the RAM, it comes from the beginning again, R1, R2, R3, R4. When R3 is loaded, now this time it will be persisted.
But sir, previously you told that if there is an action, then it will not go below of that. So
Yes.
here,
But I'm talking about this action.
yes, but sir, R3 dot collect, when it comes to the R3 dot collect, then it will not go below, na, from that.
So
how it will collect?
whenever you are saying R5 dot collect, it will read this statement. Before that, it will ask R5 dot where I R5 for R5, which is the input R4. Next, it will read this statement. Okay, I need to persist R3. Next for R4, which is the input R3.
That is correct, but sir, previously it will execute the R3 dot collect, na. So after the R3 dot collect, it will not have the R3 also, or to persist it.
If we say R5 dot collector, from where the flow has to execute, from R3 or R1?
When I say R3 dot R5 dot collect, it will be the input for the means that R4 will be the input for that R5.
Whatever it is, but where the flow has to start from for R5 dot collect? From
R4.
R4. If I say R5 dot collect, from where the flow has to start?
R1.
R1, right?
Yeah, the flow will be start from R1, but once it will come R3 dot collect, again that action will be performed, and that all the R1, R2, and R3 will be removed from the RAM, right?
Yes.
And for R4, there will be no any input, so it will be a error here, right?
When it will be removed from the memory, then how it will collect the means how it will
R1 is there,
Yes.
R2 is there, R3 is there. For R3, R4, R5. This is your flow. Which one? Okay. Initially, no RTD is persisted. First, whenever you say R3 dot collect, whenever you say action on this flow executes. This flow executed. First, to execute this flow, whenever you say R3 dot action collect, whenever you perform action, first we'll check from where the flow has to be started. To check it, first R3 input is R2. Is R2 available in the RAM? No, right? No, right? Again, it checks R2 input is R1. Is R1 available in the RAM? No. Again, R1 input is file. So first R1 loads, next R2 loads, next R3 loads, R3 loads. R1 loads, next R2 loads, next R3 loads. When R2 is ready, R1 removed. When R3 is ready, R2 removed. When the total output is collected, R3 also removed from the RAM. This is the first one. The output is collected. Whenever you say R3 dot collected, the output is collected. But when you are executing the second one, R5 dot collect, where it has to execute the flow? From where it has to execute the flow? R5 dot collect. From R1 or R3?
R1.
So first it will check R5 dot collect means R5 input R4. Is R4 available in the RAM? If it is R4 already persisted, when you have executed another flow, in that flow, if R4 is persisted, directly R4 to R5 will be your flow. But in the previous flow, nothing is persisted, right? Now,
But sir, there will be a line by line execution.
let me complete. R4 input is what? R3. R3 input is R3. Is it available in the RAM? No. But during this checking process, R5 input is which R4 input? There is a statement persist R3. So R3 input is R2. R2 also not available in the RAM. R2 input is R1. R1 input is 5. Now the flow will be in this way. R1 to R2. R3 means I need to start from the beginning. But there is an instruction given. Try to persist R3. Now it will be persisted. You have given one now. During this action execution, there is one statement given before this action itself. Persist R3. Now R3 persisted. When R2 ready, R1 removed. When R3 is ready, R2 removed. When R4 ready, R3 won't be removed. When R5 ready, R4 removed. When the total output collected, R5 also removed. Now what is in the RAM? R3 in the RAM. That is what the flow. Hello?
Yes, sir, when it collect the R3, at that time it will persist R3. You are saying like that.
So when any time in the persistence, right, when that particular RTD is loaded, see, now R3 loaded, R4 loaded, R5 loaded. Whenever you are giving that steps, right, after R5 you have given persist option, means before action. When first time the RT is loading into the RAM only, it will be persisted.
Sir, there is a no line by line execution of the code now here.
See, 1 second. See this flow. So LMONPON, this is G say. So here N input is O, P input is O, G input is O, right? So here we have given the names as R1, R2, R3. You can give any names, any names can be given, right? Whenever you are executing this flow in this way. L after L, M, O, N. This is what the flow execution of this first flow. Second flow execution is this. See, this flow execution means after L, M, D is executing. Means here, see the flow execution. First, LMD. So here also, what is it? So here, after writing some steps, think that you got 50 RTDs. After R40 input is what? R3 dot some transformation, you got R40. Means what is your understanding there? R40 equal to R3 dot transformation. R3 output you take and perform some transformation, R40 you got. R50, R5 dot, R5 output you have taken, perform transformation, R50 you got. Means it doesn't mean that continuously for R5, R4 only will be the input, not like R5, it can take R2 dot, right? Or R1 dot it can take.
Instead of R3, if we persist R2, then will it be valid or not?
Instead of
R3, if we persist R2,
Hmm.
it is also valid, right?
in this, okay, in the second flow it will be persisted. In the first flow it won't be persisted. The second,
Yeah.
when the second action is executing, it will be persisted. In this first action, it won't be persisted.
So it's like the compile interpreter. It's compiling the whole code and then it's executing.
So the flow execution, right? The flow execution, right? See, whenever you are giving this flow, whenever you are giving this flow won't execute until you give an action, right? This flow won't
Until we give the last action. So
until the
always
last
it
action,
takes
this flow won't
always
take.
it takes the last action.
This flow won't be just like you may define some 4 functions, functions, right? 4 functions. If you're not calling, do you think Python statements executes from line to line, even if 5 functions are defined without calling? Do you think they get executed? In a program code, 4 functions are defined, but there is no function call for that. But if they are defined, but you said as Python statement should execute from top to bottom, do you think will the 4 functions gets executed when they are not called? No, right? Here also the same thing. If you make action only, then this entire from this flow will be executed, one by one will be loaded. During this flow, compulsory, from where this R5 has to get the input from there only it will get. It is here R4, but it may be R4, it may be R2 also, right? If there is a big flow in zigzag manner, it doesn't mean that immediately the next RTD only should execute. It may execute the next other RTD. So persistence options, memory only, memory underscore disk only, disk underscore memory and disk. RTD will be persisted. RTD will be persisted in RAM. In object format. In object format. RTD is persisted in RAM in object format. See the difference between this first two? See the difference between the first two, memory only and memory underscore SCR only. What do you mean by serialization? What do you mean by serialization? Memory underscore SCR, right? Converting object to byte. Converting object format to byte format. See, RTD will be persisted in RAM in object format only. See the difference between first two, memory only and memory underscore SCR. First one, storage. Storage within the RAM, where in memory storage will be within the RAM. Here also the storage will be within the RAM. Within the RAM level. Here the format, in what format? It is persisted format. In what format it is, means in object format. Generally, right, RTT will be persisted in RAM in object format. But whenever you say memory underscores SCR only, in what format? In what format it is persisted? In byte format.
Bytes.
Byte format. Byte format. What is the advantage here in memory only? What is the advantage in memory only? High speed.
Right.
Why you get high speed? Because no need to deserialize. No need to deserialize. Because RTD is already in object format. What is the advantage here? What is the advantage in memory underscore SCR only? Advantage.
Yes. Space reduction.
Less memory space. Less memory space, right? Byte. Less memory space.
But will be lesser advantage, right? Because we have to deserialize here.
Yeah. Less occupancy. Here there is less occupancy in RAM. Less occupancy in RAM, right? Because of, why less occupancy in RAM? Because of serialized format. Serialized format always will take less space. So serialized format. Serialized format will save 50% of occupancy. So bigger RTDs can fit into RAM. Now, disadvantage here. Very simple, right? Disadvantage. The advantage here will be disadvantage here. The advantage here will be the drawback here, right? What is the disadvantage?
More memory consumption.
Yeah, more memory space. More memory space. More occupancy in the RAM. More occupancy in the RAM. Because of object format. Now, what is the disadvantage here in memory only? Memory underscore, yes, disadvantage here.
Speed.
Need to serialize. It
The
will
advantage here is
less speed.
less speed. Why less speed here?
to this.
Because during a computation, right? RTD has to be RTD has to be deserialized. RTD has to be deserialized. And should be converted into object and should be converted into object format.
Means serialized. Na?
So here drawback is less speed here. Here drawback is more space consumption. Here memory only high speed. And here advantage is less memory space. Now, see the next one, disk only. See the difference between disk only and disk underscore SCR only.
How do we give the option, like which memory I wanted to save that RTD?
RTD.persist within the persist bracket, right? We need to give this.
Is this constant or what?
RTD.persist, these options, where you will specify these options means in RTD.persist you will do, right? In that persist only you need to give this option. Where you want to persist, in memory or in disk or memory and disk.
So in bracket, is this memory only is constant? It's can you give one example? How do we give it this?
It will be persisted in memory only, in object format. If you give instead of memory only SCR only means it will be in byte format.
So is
Oh.
it mandated to provide any of the values? Or is there any, if we don't give anything by default, it will take memory?
Default it takes memory only.
Okay.
Disk only, if you take a disk only, right? Yes. Okay, so in both the cases, if you observe in both the cases, right? In both the cases, the RTD value is bigger. Which cannot be loaded into RAM. So flow execution fails. So we can persist that RTD into disk. Disk only and disk. So here, what is the storage here? The storage disk. Here the format will be what format? Object format. Here storage will be disk only. Format will be byte. And remaining advantages in this remain same. This advantage and this. But only thing is storage.
Sir, which cannot be loaded into the RAM. I not get that statement.
Which one?
That which cannot be loaded into the RAM. Execution fails. What
See
does
here,
it mean?
see here, your RAM capacity assume 10 GB, but your RTD capacity 20 GB. Will it be loaded into RAM?
No, no.
In such case, you go for disk. If your RAM is only 10 GB, but your RTD capacity 20 GB, so if unable to load into RAM, it will be loaded into disk. So the storage
So
is
automatically it redirects, or we have to instruct in the code?
So if you say disk only, right, it will be stored in disk only. You already know that my RAM capacity is small. So persist in disk only. We are giving the disk only option.
So sir, in runtime, let's say we don't know tomorrow,
If
maybe the
for,
RTD size is
for
more.
example, okay, I understood your query, but if you give memory only, but that much of memory is not available.
Mhm.
So you are saying persist memory only. In such case, your execution fails.
Mhm.
Don't loads into disk. There is one more option. There's one more option, right? You asked a query, right? You don't know what will be that size. In such case,
Yes.
go for memory and disk option. If memory available, in memory it will. Otherwise, it will store in disk. But if memory not, if this disk only option, if you are giving memory only, right? If memory only, if you are giving, if that memory not available, it will be failed. Execution fails.
And sir, in disk only, there is no role of the memory.
So here, what is the advantage of advantage of disk over memory? Advantage of disk over memory. What is it? Larger and bigger RTDs. Can be persisted. What is the advantage of memory? Of memory over disk? What is the advantage of memory over disk? RAM computing
It's faster.
faster than disk.
Yes, loading will be the faster.
So here, okay, what is the advantage of memory is speed. Okay. And memory, and see the last option, right? When to go for the last option. Memory and disk. Memory and disk. For example, you see, right. First time, for example, first time RTD wants to load. No space in RAM. No space in RAM. If you give this option, right?
Then it will load into the disk.
Instead of execution failing. It will be loaded into disk. After some time, RAM available. After some time, RAM available. Means why no space in the RAM? Because already the other RTDs are computing. Why no space in the RAM means already the other flow is executing. That's why no space in the RAM. Now, after some time, RAM available. Then it will be removed. Then it will be removed from the disk. Loads into RAM. So here, what is the storage? Where it is stored? The storage, right? RAM or disk? RAM or disk? But the preference.
So, Vijay, so once the space is available in RAM, right, you are saying that automatically from disk, the RDD will be loaded into RAM. Is there any specific underlying algorithm which takes care of this job, or we need to specify any steps for this?
Now in memory and disk option, right? Whenever memory available, immediately it will. So here also there are two cases. Here also there are two cases. I'll show you with some example, right? Memory and disk, how it is computed. So here format will be object format. Here format will be object format. Advantage. I'll just we'll discuss two examples here. Example one, RTD size. RTD size equal to 8 GB. RAM size also 8 GB. Assume currently other RTD in the RAM. Current other RTD in RAM. So for example, only 5 GB available. So only 5 GB available. In this case, so first RTD persisted in disk. And after some time, if RAM becomes free, will be loaded into RAM and persisted. Observe this example too. R1 5 TB, R2 5 TB, R3 100 TB, R4 5 TB, R5 also 5 TB, R1, R2, R3, R4, R5 5 TB, 5 TB. So where R2, R1 is computed. So for example, 10 machines. You got 10 machines. 5 TB memory each. They've got 5 TB memory each. Total memory how much? 50 GB, 50 TB. But 100, still this 100 TB cannot fit, right? Still this. Mhm. 5 TB memory each, right? Total memory 50 TB. Now R1, right? R1. Computed at RAM. R2 also computed at RAM. Because 50 TB available, right? Yes. Now R3, right? Computed at RAM or disk? Disk level. But its output is
Object format.
but it's okay, a computed disk, but its output is taken from disk by R4.
So we are talking about persistence, right?
Compute set RAM.
So we are talking about persistence, right?
Yes, yes.
So computation will always happen in RAM only, right?
So this 100 TB, right? 100 TB. So whenever you are persisting, right, you cannot persist. It cannot be persist, even though if total RAM is free also, 100 TB, it cannot be loaded into that. But its output is collected by R4 and computes at RAM. So whenever you are persisting in RT, R3 should be persisted in disk only. It will be available in disk only.
Yeah.
R3 will be available in disk only. But
Yeah.
R4 input is what? R3 output. How R4 is going to collect, from where R4 has to collect the output? See, generally,
Yeah, but
whenever we are discussing about the data flow, right, the importance of persistence is it will be available in the RAM even though the next RTD is ready. That's fine. But here, R3, if you are per R3, where it will be available, where R4 has to get the input from, where R4 has to get the input from the RAM or from the disk?
yeah, from the disk. But here you see R3 computed at disk, but its output from disk by R4. So computation will always happen in memory only, right? Storage, its state is either persisted in RAM or in disk, right?
Yes. So, but here R4, where it has to collect it, where it has
From
to
the
collect
disk.
from the disk only, right? Not
Yes.
from the memory. It won't be available, right? So
Yes,
R4 input has to be collected from the disk only.
Yes, sir.
And
But
computes at RAM.
yeah, computes on RAM.
Yes.
But this computed at disk, right? That is what I was confused by.
Means okay, persisted at a disk level, right? Persisted within the disk level
Yeah.
only. From the disk only, it has to collect the output R4.
Yes,
And
sir.
R4 again at RAM level.
No, sir, you have put it like computed at disk. It should be persisted at disk, right? In the 100 TB. The first place it's fine. The third point, I think he's talking about. Yeah.
Okay.
So there is no persistence of R1 and R2, right? Only we are persisting R3.
Okay. Persisted in disk, but its output is taken. Okay. This is also at RAM. This is also at RAM. So here, what is your understanding here? R4 is going to the disk and takes its output and loads into this RAM and computes R4.
So we are persisting only R3. So R1 is computed in RAM, R2 computed in RAM.
If, for example, if R3 is fits into RAM,
Yeah.
if, for example, if R3 also, if it is, if the RAM size is, if this size is smaller, then it can be loaded into RAM. It will be persisted into RAM. Yes.
Vijay, in this scenario, right, R4,
Mm.
so it takes the input, input from the disk, right? And you're saying that computes at RAM, but since that size is 100 TB, right? How can it compute at the RAM level, that R4?
See, R4 means if 100 TB is there means, and R3, if, how 100 TB became 5 TB?
By applying any filters?
Yes, filters. Of 100 TB, if you perform some filters, I want only particular city data, the 5 dB data. That will be stored and computed within the RAM level and gives the output to the next RTD. Yes, so these are the different 5 ways, right? Persist options. Here the 5th option is if memory available, persist in RAM. If memory not available, persist in disk. And here, if you think, if you're confident that memory is not at all available, then you can go for these options. If you are very much sure that memory is full available, you have got a good memory, right? Means a huge memory, bigger memory, then go with this memory option. And if you are uncertain, right, go for memory and disk option. So 2 ways to persist an RTD, 2 ways to persist.
What could be the recommendable to take this one? Memory or RAM or?
See, if you are
only
if you are maintaining good RAM, if you are maintaining a good RAM capacity, right? Then go for memory only.
But sometimes RAM might not be available, so we can use the third option, right? Memory and RAM.
Memory and
so that
memory and disk
yeah.
used.
Is there any performance issue will be there in memory and RAM or any?
See, only one advantage you see here is it won't fail at all. If you are giving, you are very much confident that the job executes memory and disk. But memory only, there is a chance of your job failing, right?
Correct. But memory and RAM, there will be some latency or maybe some slowness, right? Because we are storing sometimes in
Memory
disk
and maximum, it takes the first preference memory only. First preference memory only. See, 2 ways to persist, I said, rtd.persist and rtd.catch. 2 ways to persist an RTD, right? rtd.catch. What is the difference here? Two ways to persist.
They can be only in memory.
Can use all persist options. rtd.persist. memory. R3 dot memory only. R3 dot catch, right? It can use only one option. Can use only one option. You're using catch. We cannot control the persist options. We cannot control the persist options, right? For example, try to say this: two clients submitting two jobs simultaneously. Two clients submitting two jobs simultaneously. Observe, this is that R1, R2, R3, R4, R5. R1, R2, R3, R4, R5. This is the first flow. This is the second flow. This is flow 1, this is flow 2. For example, client 1, client 2. Client 1 executing flow 1, client 2 executing flow 2. Now, are they both executed parallelly? Whenever you will say like R5 dot collector. You will say R7 dot collector. Now try to answer both the flows executes parallelly. What it means, I mean to say, client 1, client 2. So R3 is persisted here. R3 is persisted. Do you think client 1, client 2, both will be executing from the beginning, or what is that answer? It's when one flow, other flow, they make from R3 to R. Whenever you perform collect R7.collect, do you think our client flow 2 will execute from R1 or R3?
From R3, I believe, because R3 is persisted actually.
Everyone try
And
to answer.
simultaneously.
From R1.
Will it execute from R1 or from R3?
From
R1.
R1. Both are submitted.
See, for example, first client 1 executed the flow. After some time, after the entire flow executed, a client 2 executing the flow means in such case R3 remains in the RAM. So whenever the client 2, whenever it triggers a R7.collect, flow executes from R3 to R7. But here client 1 and client 2 both are submitting 2 jobs simultaneously. Here what happens? Both the flows starts from the beginning. Because whenever you say R5.collect, R7.collect, in both the cases, R3 is still not persisted. Both. So both the flows should start from the beginning. But one flow, the flow 2 can reuse this R3 output only when the entire flow 1 is executed only, then it can reuse that flow 2 output. Understood, right? Yes.
So instead of it, Vijay, we can schedule the job set to, 3 jobs. One job is for running the R1, R2, R3, and then we can have 2 dependent jobs like R4 to R5, R6 to R7. So in that way, even if a client submits the job, right, since we are establishing he needs to trigger that first job, right? So that job runs and then simultaneously dependent jobs run, right?
Whenever you are doing anything parallelly means you cannot reuse the transformation. Whenever that jobs are submitted simultaneously means you cannot, means at least one, what is that persist option, right? What is the main feature of persist? To at least one flow has to be executed. If you want to persist an OTT, at least one flow has to be executed. One job should be executed. Until then, the persist won't happen. Here, if I say R3, somewhere if you got some 50 R1 to R50 to persist R30, the first flow at least has to be executed. Until then, the next flows cannot use that. I already executed transformations. Next, creating OTDs. Creating OTDs. 3 ways. Three ways to create OTDs. First way, when data is loaded from a file using Spark context, means using SC only. For example, sort Spark context dot text file F in uppercase, case sensitive, right? SC dot text file, right? Here you will specify the path of the file. file 1, comma 10. Here 10 indicates number of partitions. Here 10 indicates. So in the case of Spark, you can control the parallel processing, I said. If you use 10, it will be into 10 partitions. If you use 5, there 5 partitions. The 10 indicates number of partitions.
If I will not give anything, then how many partitions will be happen? Second option.
RDD1 is created, right? Whenever you say sc.text file, whenever you load, 10 indicates the number of partitions. So here you can also say how many partitions you want. So to know how many partitions, RDD dot get num partitions, n capital. This is going to return the number of, to know how many partitions, RTD dot get num partitions. Next, second way, how to create RTD is when you perform filter or transformation over a RTD, then the output RTD1 dot filter. On RTD1, you perform some filter operation. You have just given some condition based on CTR, based on department number. RDD2 is created. RDD2 is created, right? That is second way. Next, third one. When you parallelize Python or means converting a Python object to Spark object. That is converting a Python object to whenever you say r5.collect, what is res here? Here res
An object.
Python object or Spark
Python
object?
object.
Python object.
Python object. Whenever you perform action, right? Python object. Not a RTD. I want to make res as a RTD and makes it output and makes make its output available to multiple RAMs.
Sir, I want to ask one thing, like if you see in RDBMS, we create multiple temporary tables and perform joins and then create a final target table.
Mm.
So if we compare that scenario into this Spark, then how do we, so are we going to create the same temporary tables here also?
Temporary tables here, what is the temporary tables? Yes, here also we are going to create temporary tables, but here we use concept like data frames.
Okay.
Means data frame is nothing but an RTD with schema. We call it like a data frame. RTD with the schema is nothing but a data frame, like a table structure you will get. And that if you want to create temporary tables and perform SQL kind of querying also we can do using Spark SQL by Spark SQL, right? So how to parallelize, right? How to parallelize means, for example, SC dot parallelize, RES, store the output in RTD 4 equal to SC dot parallelize. So RES is a Python object. RTD 4 is what? Spark object. So these are the three ways to create RTDs. One is directly creating by using Spark context from a, whenever you perform any filtering or transformations, right? Then RTD created. Whenever you parallelize Python object, you will get it. And RTDs.
Vijay, if I want to see the output of an RDD, right, is there any command in Spark?
You want to see the output of an RTD.collect, it will collect the entire thing and displays the output.
Okay, so finally we need to convert that RDD into a Python object, basically Spark. Then only we can see that result, right?
No, on RTD directly, if you say collect, you will get the output. You will get the result. You will get the result. Will be displayed. So, if you, what do you mean by collect? Collects all the partitions present in different RAMs and displays those. If you got 100 records distributed, 1 lakh records distributed across multiple RAMs, all those will be collected and will be displayed.
So we don't have an option to see basically what is the output based on the partition, right? In that partition, what is the output basically?
Partition wise, you can see the output. I'll show you in practicals, right? From tomorrow, we'll go with the practical part. Yes. Yes, we can see partition wise, you can see the output. For every partition, right? You will get one file, separate file. For every partition, one separate file you will see in the output. If RTD has got 3 partitions, 3 part files you will get. Press up it into 4 partitions, 4 part files you will see. RTDs are immutable. RTDs are immutable, right? Immutable means on here, on RTD1, if you are performing something, right? Original RTD remains same. But you just perform filtering, you got a new RTD2. But don't think this is an RTD1, it will be same, unchanged. On RTD1, if you are performing some transformation like filtering, a new RTD2 is created. RTDs are immutable. You can modify an RTD. Okay. RTDs are immutable means whenever you are performing some filtering or transformations, a new RTD gets created, but the original RTD is the same. Okay, fine. So then I'll be discussing what are the various RTD transformation, one by one transformation, one by one action in brief, right? So tomorrow we'll go with the practical part. So I'll be forwarding. So those who have already they're done with Hadoop, right? Those who are learning Hadoop, already the software, whatever I provide in that, you can use that Spark. But I'm the other people, right, who are joined, right, who doesn't have that software I provide, I'll be forwarding to your Google Drives. And by today tonight, I'll be forwarding. You can just download it, extract it, right? And tomorrow I'll just demonstrate about it and I'll show you the executions, transformations. I'm going to show you the transformations and actions. In that also, there are key value transformations are there. What are the different transformations? So the file I'll forward now itself, right? I'll just keep in this chart, this whatever notes I'll keep in the chart. You can just check it. Tomorrow, same time, 6:30.
Vijay, is there any WhatsApp group created for this batch?
So, okay. One second. So, yes, so 1 second. Tomorrow, okay, a link you are going to get right to your mails just before the class 6:30. The class will be up to the end of the course. The class timing will be at 6:30. So you will get a link to your mail IDs. The link will be the final link up to the end of the course. You follow the same link. There won't be any change in the timing or in the link from tomorrow, right? You can check one link forwarded to your mail by this online team. Still, if anybody not enrolled, right, you can just enroll. You can see that, right? And WhatsApp groups, okay. Just ping me on this number, right, to get added into the WhatsApp. Just ping me on this number. Give a WhatsApp message, right? If anyone, right, if you want to get added into the WhatsApp, just ping me on
Number,
this.
pin.
Okay, 9912621686. Just ping.
And the software installation steps and instruction also we would need probably.
Tomorrow I'll show you all those. Tomorrow onwards we'll go to the practical part. There won't be any theory from here on, right? So everything we'll be seeing practically. Up to now, you know all the RTDs, computations, the persistence, and the different ways of creating RTDs, and the different persistence options. Yes, all this. Fine, and fine. Tomorrow, different types of actions and transformations. Different types of transformations and actions. Okay, fine. So I'll stop for now. We'll continue tomorrow at 6:30. A new link to your mail IDs. Okay, fine.
Please share the documents.
No, 1 second, 1 second.
Can we get the video lecture for this to our drive?
Can you see now, right? If nodes is loaded into this chart, so you can just copy it. Never, right? In this chart, you can see it, right? Okay.